Okay, so the next step in our set of tutorial videos, what we're going to be doing is importing an earthquake file that we've downloaded online and putting it into SAP and running a modal analysis on it using the beam that we created in the past videos. So the first thing that you want to do is navigate to this website, ngawest2.berkeley.edu. It's a ground motion database that essentially takes large volumes of data from earthquakes in the past years and puts them out there for the public to see. So when you get to the website, it's going to have you sign up for an account and create a login, so just make sure you start with that. And then you'll navigate to the screen that I see right here, and we are going to click this blue icon right here on the bottom, NGA West 2. So we're going to go to that. As you can see, first up, we have this dialog box that says Target Spectrum. We are going to make sure that the models to generate target spectrum is set to Peer NGA West 2 spectrum. From there, in the next box, we're going to click Load Sample Values and hit OK. And that's pretty much just going to import all the default settings on the website, and then scroll down to the bottom and hit Submit. So from there, we can see that we have our target spectrum created. And now we are able to search records that are imported onto the website. So we are going to navigate to the bottom where it says Search Records right here. Click on that. And essentially what this does for us is gives us a lot of different user data points that we can input and find different earthquakes all around the world. So one of the easiest things to do is under event name, just type in a country, so like Japan or United States. In this case, I'm going to be using Italy, so just type that right in there and hit Search Records. So once our search is successfully created, we can navigate down to the bottom and see all of the metadata, and you guys can organize it by the event, the year, the station that is collected at, or the magnitude, pretty much anything right here that you see. If you chose a country that has a lot of different earthquakes, instead of giving you all the data, it'll give you the first 100 results, and from there you can sort through and see different ones. So as you can see, we have all these different data points. For this case, I'm going to just choose the first one right here. So an earthquake in Italy in 1976, that was a 6.5 magnitude. So in order to view the earthquake, just click this view button on the top left and scroll back down, and we can see all of the imported data from the earthquake in that specific year. So in order to display the time history of the earthquake, we're going to navigate down to Results, and in the Display Time Series of selected record, we're going to choose Unscaled. So that will just reload the page that we're on, and then we can see, scrolling down to the bottom, the time history graphs that it gives us. So it's going to give us horizontal components of acceleration versus time, velocity versus time, and displacement versus time for different points recorded for the earthquake, as you can see right here. So in order to get this data, we're just going to select the little checkbox right here and click Download Time Series Records. So the data that we download from the website is going to be downloaded as a zip file. So it's just going to take a little bit since there is a big volume of data being downloaded from the website. But once it's downloaded, just open up that zip file, and we are going to be looking at AT2 files. So you can just select one of them. This type of file is going to open in Notepad, so we're just going to click that first one right here, and you'll see opening in Notepad. So what we want to do now is go to File, Save As, and we're going to save it as a text file. So in this case, I actually already have one saved, so it's going to be SAP example.txt right here. So just make sure you save it into a spot where you can find it once we go into the SAP portion. Now that we have our earthquake file downloaded onto our computer, we're going to be moving over to SAP. And the first thing we want to do is enable a quick simulation of different input frequencies. In this case, we're going to be using our earthquake. And in order to do so, we are going to input a sine function generator into SAP. So to do that, we're going to go to Define, scroll down to Functions, and then hit Time History. From there, we are going to switch this function add to from file, since we have that text file downloaded already. We're going to add a new function, and just like we've been doing with the past parts of this video series, we're just going to change this name. I'm going to choose the name Italy because our earthquake was downloaded from Italy. You can choose whatever name you want as long as you can keep everything lined up when we're adding different files into the program. So once this pops up and we have everything added in, we can see that the first thing we see are the values at equal intervals. This value right here is going to actually be something that you find in the data sheet that you just downloaded from the internet. So that AT2 file that you converted into a text file, open that up, and we can see right here that this DT of 0.005 seconds, that is going to be our time interval. So just make sure that when you go into SAP, you switch this to whatever value that you have at the top of your data sheet. So the next thing that you're going to want to do is input that text file that we were just looking at that was downloaded from the internet. So under the left bar we see function file, we're going to click browse, and then once again navigate to that downloaded text file that we were just opening. So just import that file right there, and as you can see on the bottom, SAP displays a function graph of whatever data that we just put in. So from there, just hit OK, and we'll have everything loaded in. So you can see that under the functions box, we now have the time history function that we just imported. So mine is named Italy. Once again, yours can be whatever it needs to be. The next thing that we want to do is define our load case. So we're going to go to define, scroll down to load cases. And as we see from past examples we've been working on, you guys should have a dead and a modal case from what we've already done in previous videos. So what we're going to do is add new load case. Once again, just change this name from the default to whatever name you set for your time history case, just so we can have some fluidity in between the two. Navigate over here to load case type and make sure to change this to time history, and we'll see that that dialog box will update along with it. So for the analysis type, we'll have it set to linear, solution type will be modal, and then history type will be periodic. So just make sure these three values are all the same to what you're seeing on my screen. From there, we're going to navigate down to loads applied. The load type should be acceleration. The load name will be U1. Function will be whatever time history function you just set up previously. And our scale factor is going to be 386.4. So just make sure when you're done, you add that in to the program. And then the last thing we're going to do is edit the number of output time steps and the output time step size. So the number of output time steps is going to be 10 times the number of cycles. So in our case, it's going to be 100,000. And then the output time step is going to be 1/10 of the period. So I'm going to be using 1.0 times 10 to the negative 3. So after we have all that set up, we're just going to hit OK. And then we'll see that once again, our new load case, mine being Italy, will pop up on our load cases in the dialog box. So just exit out of that, and then we're all set. So we're going to run our analysis by clicking that play button on the top bar. And then we're going to make sure that the only thing that we have running is the case that we just created. So in my case, it's going to be Italy. So make sure that you set everything else to do not run so that SAP is only analyzing the time history that you had just input. So go to run now. So from there, you'll see pretty much no change. It'll just be your beam once again. One good check that you want to do is make sure that this period and frequency at the top that you see displayed still matches up with the period and frequency that you got in the past video. So we're not changing any properties of the material or anything like that. It's going to be the exact same beam. The only thing we're doing is, instead of applying a force or doing a point load, is we're running a time history using the text file that we imported from the Berkeley website. Once you've run your analysis, you're going to want to display the acceleration graphs that SAP has analyzed. So we're going to go to Display on the top bar, and then navigate to Show Plot Functions. So your screen should look something similar to this. We'll see that we have our load case right here specifies as Italy, because that's the only thing that you guys should be running right now. A list of functions, vertical functions, our time range, and the axis override. So the first thing we're going to want to do is define the plot functions that we are looking at in SAP. So click that button right here, and we are going to make sure that this function type right here is set to load functions. So we're going to click this button, add plot function, and you'll see that we have acceleration in 3 directions and a dead case. you're going to want to add all 3 accelerations. And then you'll see them right here pop up on the plot functions bar. We'll hit OK. And then once again, we'll see them in the list of functions right here. We're going to click on this first acceleration that we put under the list of functions and add it into vertical functions. We'll see that on the bottom of the screen right here, the selected plot function line options will light up so we can make some edits. Essentially what this is going to do is display the plots for the top node structure in response to the acceleration on the graph that we're viewing. So we're going to want to make sure that we have solid line checked off, and then we're going to keep that vertical scale factor to 1. So from there you can just hit display. So we'll see that SAP will have a nice display of acceleration versus time on the graph that we see right here. If for any reason you only see your graph in this small portion right here and then a straight line for the rest, what you're going to want to do is adjust your x-axis. So in order to do so, we are going to look at the axis range override right here and click on that horizontal one. I have mine set to 0.10 just so that I can see as much of the graph as possible. So once you have this, you're just going to want to take a quick screenshot of this, and we're going to be comparing it to the text file that we just downloaded to make sure that everything matches up correctly. Okay, so the last thing that we're going to want to do for this step of the video series is we're just going to want to compare that initial text file to the graph that we just created in SAP. So in order to do so, we're just going to open up Excel, and we want to import our text file into Excel so that we can create a graph from it. So we're just going to go onto the top bar and click on Data. On the left, we'll see that there's different sources that we can import from. So we're just going to do from text since we have a TXT file. And then once again, just find your text file. So right here, mine is SAP example, and we'll import it. Make sure that you have the file type set to fixed, just so that each of the individual numbers will go into their own cell rather than everything going into one cell. And just hit finish. Make sure that you have it set for that first grid cell in Excel, and then hit OK. And we'll see that all of our data has been imported from our original TXT file. So the last thing that we're going to want to do when looking at our TXT file that has been imported into Excel is taking all this data that we've collected and basically making a graph of it so we can do a comparison to the graph that SAP has output. So as we can see right down here, I have a graph of the input ground acceleration versus the time. So we want to think back to that time input that we had of 0.05 seconds. If we multiply any of these values on the x-axis by that 0.05, then it'll give us the time in seconds for our earthquake. So as you can see, we have this graph right here with 4 different series points, and we can always go back to SAP and look at that graph that we had just seen before by going into the display and looking at the plot function and comparing it to the graph that we have in Excel. So as you guys can see, the graphs are very similar, which is exactly what we want.